Hello, Professor. This is for question 4. This was about the aluminum cylinder, and you were primarily asking us to find the angular momentum and the kinetic energy for its rotation, or its rotational kinetic energy. These were the initial numbers that I got when I plugged in my phone number, and we had to solve this for it being on Mars. The initial formula that I found for the inertia formula, rather, for cylinders was this, and this was the one that was for the mass just in itself. When I plugged in the numbers, the mass that I found was 95,000 kilograms per cubic meters, and there was a lot of confusion on this one. Primarily the idea that for a cylinder, you actually meant something that has a hollow basin, and for maybe the first hour I was only working on a solid object, and then I realized that you actually have to find something that works for only the diameter and the perimeter. And that would mostly be this. It was this part right here that I was missing. And after I got that, I was able to realize that it's the first radius and the second radius, and that's what lets me actually calculate the angular, the moment of inertia times the angular velocity. And when I do all of this out, and I know I wrote up here 2 pi, or a 79 without the 2 pi, but it's actually 2 pi over 79 because it has to rotate the entire unit circle, or one full revolution. And what it totaled out to be was 1.5 million kilograms squared per second, and that's its angular momentum. And then for that, it was just to punch in just for the kinetic energy, and it's just 1/2 the moment of inertia for this specifically, and the rotational velocity squared, and it gave me 58,000 joules, just say 59,000 joules. But that's what I got, Professor, and thank you very much.